sort, which is a way of sorting arrays so that they end up ordered. I'm gonna show you a little animation about that, about bubbleSort before I go on to coding this. So for example, this is from Wikipedia. If you Google bubbleSort on Wikipedia, you will find this. And the animation goes as follows. You have an array 6, 5, 3, 1, 8, 7, 2. You compare the first two, and if the second one is bigger than the first one, then you swap them. Now here, 6 and 3. 6 is bigger than 3, so we swap it. I compare 6 to 1. 6 is bigger than 1, so I swap 6 with 1. I compare 6 to 8. 6 is not bigger than 8, so I continue with my window. I compare 8 to 7. 8 is bigger than 7, so I swap them. Then I compare 8 to 2. 8 is bigger than 2, so I swap it. Right? Then I'll compare 8 to 4, which is the last comparison. Because 8 is bigger than 4, I'll swap them. I have done one pass through the array, and there were comparisons. So I will keep doing this until there are no comparisons. I compare 5 to 3. 5 is bigger than 3. I swap them. I compare 5 to 1. 5 is bigger than 1. So I swap them. I compare 5 to 6. And 5 is not bigger than 6, so I continue. 6 is not bigger than 7. 7 is bigger than 2, however, so I swap them. And then I will compare 7 to 4. 7 is bigger than 4, so I swap them, right? And then finally compare 7 to 8, which nothing happens. So I go back. Because there were comparisons, I have to go back. Compare 3 to 1. There were 3 and 5. They stay the same. 5 and 6, they stay the same. 6 and 2, 6 is bigger than 2, so I swap them. I will swap these two. Then I compare 6 to 4. 6 is bigger than 4, so I swap them. And then I will compare 6 to 7, and 6 is less than 7, so I leave it there. And 7 to 8. I go back. 1 to 3, 3 to 5, 5 to 2, I have to swap those, right? And then I will also swap 5 with 4. Notice how the biggest numbers are becoming sorted at the end of the array. I'll compare 5 to 4. 5 is bigger than 4, so I swap them. Because I've swapped elements, I go back. I compare 1 to 3. I leave that alone. 3 to 2. 3 is bigger than 2, so I swap those. Right? And then I compare 3 to 4. They're in order, so that's fine. I did one swap, so I have to go and compare this again. I swap the 2 and 3. 1 and 2, no swap. 2 and 3, no swap. And no swap on the other ones. So I'm done. The array has been ordered. Okay? And that is how bubbleSort works. It leaves the array in order that way. Now let's code this. Well, so let's create a class, public class. I'm going to call it array sorter, and it will have a main method, just because I want a main method. Public static void main string args, and I am going to have a public actually I'm not going to have a main method. I'm just going to have a sort method. Public, this will return an array. So let's say it's an int array. bubbleSort, I'll give it an int array, r. And what I'm going to do is I'm going to replicate this algorithm that I just showed you. So first I'll have a Boolean variable called swapped. It's going to be true, false, just so I can try loop. Now, remember that we were comparing adjacent elements, so let's code the comparison. You know, for one pass, for int I equals 1, I less than array.length, I plus plus. Why am I going to start in 1? Because I will compare. You'll see, because I'm going to compare the previous element. So if r sub I minus 1, okay, is greater than r sub I, then I will swap these two things. then swap. I'm just going to leave it like that for now. And if then swap. Oops. Then basically this is what I'm going to do for one pass of the array. Let's look at this code for a second. I'm going to go through each element of the array comparing. Say I is 1. I'm going to compare element 1 minus 1, which is 0. I'm going to compare element 0 with element 1. And if element 0 is greater than element 1, then I'll swap them. And so on and so forth. So I'm going to go now to element I is going to be 2, so I'm going to compare 2 minus 1, which is 1. I'm going to compare element 1 with element 2, element 3, element 2 with element 3, element 3 with element 4, and so on and so forth. Okay? And if basically this is the previous element is bigger than the current element, then you swap them. Okay? Then you swap those two. And you will do this, right? This for loop goes through the array once, but you'll go through the array as many times as necessary until there are no swaps in your run through the array. So what we will do is we'll say, while there are no swap, while nothing is swapped, do this for loop. Okay, the if. This is the for loop. Always be careful with indentation, and I'm gonna go in here. All right. So while we don't, as long as we swap something, while nothing, while swapped. This should be while is swapped. While something is swapped, let's do true. Okay. As long as there's an element that's been swapped, I'm going to go through the array and swap elements, right? So now, how does this swap work? Well, the swap works like this. So I'm swapping integer elements, right? So I'm just going to leave the comment. So I'm swapping integer elements. If the previous element is bigger than the next one, and the current one, what I'm going to do is I'm going to say, okay, these are ints, so some int temp is going to be the current element, right? Now the current element will take on the value of the previous element, right? I minus 1. And now the previous element is going to take on the value that I had stored in the temporary integer. This is a swap, right? Going from one position, swapping it with the next one, requires me saving this position onto something, moving this one over here, and moving the one back. So what we're doing here is we save the current element someplace else. Now we replace the current bin of the array with the previous element. And the previous element, we put what was before known as our current element, right? So we're swapping, we're doing this swap. You can trace this and you will see in any array that given any I, this will actually swap the two elements. Now, the thing is that if we have swapped something, well then swap should be true because we have swapped something. If we don't swap anything, this will be false. Now, for that we'll have to do a check whether we swapped. So the easiest thing to do is this, is to do here to say swapped equals true, right? So swapped equals false, I'm sorry, false. So we'll say we initially do swap equals true, so this while loop can start. So while swapped equals true, first I'm going to make it false. I'm going to assume that they're in order, right? There are no swaps to be made. And then I'm going to go over the array, and the minute I swap something, that swap's going to become true again. So then the while loop here will continue, right? And we'll initialize it to false, assuming there's nothing to there, everything's in order, right? But if something's not in order, meaning this if is true, value is true, well, the swap is also going to evaluate to true. Okay? And this is basically bubbleSort, and we should probably test this. So let's create, let's save this. I'm going to save it as arraySorter.java. And then I'm going to create a class with a main method that tests this. Okay, so file new Java public class test sorter, and there I'm going to have a main method, public static void main string args, and I'm going to have an array sorter as equals new array sorter, and then I'm going to have an int array called unsorted. That's going to be let's say 6, 5, 3, 8, 2, 1, 4, 7. There you go. Numbers from 1 to 9, I believe, and 9, 7. Numbers from 1 to 9. And then what I'm going to do is I'm going to say array sorter dot bubbleSort. That's what our method was called. Unsorted. And then what I will and I'll say unsorted equals that. I don't really need to return an array because when I change arrays, I'm actually changing them here. You should take a look at passing by reference and memory management for that. But just for clarity, I'm just going to say unsorted equals, you know, the sorted version of the unsorted. So let's say int array sorted equals the unsorted version of that, and then we'll print sorted, right? So for int element in sorted, I will just system.out.print element plus a space and a comma perhaps. All right. So let's compile this. Oh yes, sure. I want to save the file. So save as test sorter.java. Let's compile this. And I have a problem here. Int I equals 1, array.length. Oh, sure. This length doesn't go like this. There's always some debugging to be made here. And this should return an int array, which I'm not returning yet, right? So what I will do, this is the while loop. I'm going to return array, the array that I have sorted now. Alright, and then let's compile the test sorter. Minor bugs, I'm sorry, and then let's run this. This should print these numbers, the numbers from 1 to 9, all sorted out. And then it prints 1, 2, 3, 4, 5, 6, 7, 8, 9. So it successfully sorted the arrays by calling the function bubbleSort, which in turn is this function here, this method here, right, which is basically an implementation of the bubbleSort algorithm. The idea that you compare each element with the previous one. If the previous one is bigger than the current one, well, the previous one should be on the right side, and the previous one should be on the left. And that's what you do. You accomplish that by swapping. You do this as many times as necessary until there are no swaps in the array, which is what the swap variable controls.